Thank you for this opportunity. What I'm going to speak about is two parts of the work that we have been doing over the last decade, looking at phenotypes and mechanisms within autism. The word phenotype is a suitably confusing and vague word, which basically refers to anything and everything that is related to the behavioral manifestation of a condition. And we have been looking at autism quite a bit. And here, autism as a spectrum of conditions is characterized by different dimensions within the phenotype. One of these phenotypic dimensions is in social and communicative ability. The other is in repetitive behavior and restricted range of interests. And yet another dimension is sensory sensitivity. And you could think of it that people with a diagnosis, with a clinical diagnosis of autism, are represented in the extreme ends of distributions of these individual dimensions that exist across the entire population. Now, amongst these different dimensions, the one that is of particular interest to me is the social communicative dimension. And I have been kind of wondering about how is it that these differences, these individual differences in social communicative ability come about. And one of the hypotheses that was put forward is called the social reward responsivity hypothesis. It became popular in the early 2010s, but I realized that it was already proposed in late 1970s as well. But the logic of this hypothesis goes like this. So if a child from a very early age has a reduced preference for social rewards, so social rewards refer to things like smiles and pats on your back and people in general. If you do not like social rewards to begin with or have a reduced preference for them, you might attend less to social stimuli. And if you're attending less to social stimuli, you might learn less from social cues, especially in that early developmental period. And if you learn less from social cues, you might not be aware of all the social rules and unwritten customs that are followed in everyday conversation, which might come up as differences in social communicative ability. So this hypothesis is called the social reward responsivity hypothesis, but it then leads to the question of how do we actually measure social reward responsivity, and that's where I come in. So one of the standard ways of doing measuring social reward responsivity is to present pictures, the picture pairs or video pairs like the ones that you see on the screen now, with cakes on one side of the screen and happy faces on the other side, and people are presented a large number of pairs of these images or videos, one pair at a time, and they are not given any instruction. All they're told that, just keep watching them look wherever you want to. But while they're doing that, we collect eye tracking data. We collect where they're looking, how long they're looking, and how their eyes are moving from one to the other. And we made a series of these images. Now, the kind of the less fancy part or the less exciting part, but the very important part of preparing those images was that they had to be matched on a whole range of parameters. They had to be matched on color, contrast, self-rated arousal, valence, and also low-level salience. So all the image parameters had to be closely matched. And then once they are matched, then one could rule out, for most part, the role of low-level stimulus features in any potential difference that we see in how people attend to them. And then we invited adults with and without a clinical diagnosis of autism. Here is the data presented on the right. So if you see the blue bars, which is autistic adults, there is no special preference. On the y-axis is the gaze proportion to social images. So you can see that there is no preference for the social stimuli in autistic adults. They are looking equally towards the social or the non-social reward image, whereas the NT, or the stands for neurotypical, or the non-autistic group, there is a clear preference for social over non-social images. So that was that was really a kind of very useful proof of principle that yes, there's something that has been reported anecdotally quite a bit, whether that replicates in the lab in terms of preference for social stimuli as presented on screen in this case. Now, then we delved a little bit deeper into this while looking at the gaze behavior of individuals when they're processing these pairs of stimuli. What we see is that the green trace here is the non-autistic group, and the blue trace is the autistic group. And on the y-axis is the gaze proportion to the social stimulus. So what you see here is only around the 3.5 second mark. So on the x-axis is the time of the trial. Only after about 3 or 4 seconds of watching those pairs of stimuli does the autistic trace go below 0.5 or goes to 0.5 and then goes below. So the feature that I just talked about in the previous slide of reduced attention, reduced gaze bias for social stimuli in autistic adults, that actually does not kick in until quite a bit into the trial time. So if we were just going to focus on the first 3 seconds of the trial, then these two traces, even though they appear slightly different from each other, they are not statistically significant. So the only statistically significant bit is the one that's marked in red. So we identified that the time matters in how we assess social reward responsivity. It's really for extended periods where the group difference becomes more prominent. Then we probed it with yet another variation on this theme, which was to look at the coupling between gaze and choice. So in this particular paradigm, we present people with pairs of stimuli, the social and non-social, but at the end of each trial, we also ask them to explicitly choose whether you would like to have, whether you like the social stimulus or the non-social stimulus more. You have to explicitly make a choice. And now just concentrate on the red curves here. That is where we are displaying the intact stimuli. And on the top boxes that you have here from 8 to 45, they represent different levels of autistic traits. So those who on the right-hand side of this distribution, the ones above 36 and 45, they are, many of them have a clinical diagnosis of autism. Those on the left side are mostly non-autistic. And what you see here is that as the autistic traits increases, the red trace goes off the origin. So that means the gaze and the choice, gaze here on the x-axis and choice on the y-axis, they become more and more decoupled as autistic traits increases in our sample. That's also an interesting phenomenon that suggests that the explicit preference of when you ask an individual whether you like this or not versus the implicit preference of when you're not asking anybody and just asking them to look wherever they would like to, these become more and more decoupled in autism and those with high autistic traits than in non-autistic individuals. And then we have another paradigm where we present the stimuli, this time not above the level of awareness as I've presented previously, but below the level of awareness. This is using a technique called continuous flash suppression, where we present one stimulus to the right eye and a pattern of flashing ellipses to the left eye. Now, if there is a pattern of flashing ellipses to the left eye, then the person cannot really see the stimulus presented to the right eye, a static stimulus, for a few seconds. And after a while, they start noticing, and that's when they report. And what we find is that non-autistic adults, they are much quicker at identifying if that static stimulus on the right eye is a social stimulus compared to a non-social stimulus, whereas any such social advantage is not seen in autistic adults. This was really kind of taking another spin on the same phenotype, just seeing that the differences in processing social and non-social rewards does not appear only if the stimuli are presented above the level of awareness, but also when they're presented below the level of awareness. So far, I've just been talking about studies in adults. We also did a study in very young children where we looked at social and non-social reward preference. And this time, the children had to press a button, a red button to get to a social reward and a blue button to get to a toy reward on a tablet. And these buttons were kind of jumping around on the tablet. And what we find is that autistic children would press the button linked to the social reward fewer times compared to the non-autistic toddlers. And this difference was not seen if we just made scrambled versions of the same social and non-social stimuli. So this preference cannot be attributed to low-level stimulus features. Now, in summary, we find reduced social reward responsivity in autism, and we are reasonably confident that it cannot be explained entirely by low-level stimulus features, and that time, the trial time matters. The group differences grow with trial time, and even when these group differences are seen, even when stimuli are presented below awareness. At this point, I would change gears and talk about the work that we've been doing outside the lab. And in particular, a lot of my work has been focusing in India, which is where I'm from. And interestingly, and not quite surprisingly though, autism research in India has a very different landscape. There is a huge detection gap for autism in India. There are lots of existing barriers because of lack of tools and lack of expertise in wide regions, and the experts being restricted to only major cities, and huge variability in culture, language, and status. And so the first thing that we did, we wanted to take some of our research that we are doing in the labs to have an application in the field. So the first step for us was to build a toolkit. So we created a bunch of tools by translating and validating and culturally adapting for doing autism research in India. And we use these tools to generate the first prevalence estimate of autism in school children in India, over 12,000 school children in India. And but this work would not scale, because this work needed psychologists and highly trained individuals doing these assessments. So that is where we started moving towards a technological solution. And this project called Screening Tools for Autism Risk Using Technology was a consortium that I led to develop a mobile and modular platform for early detection of autism risk by non-specialist health workers. So we built an app, and this is what the app looks like. It has some of the questionnaire measures that I just mentioned in the previous slide, but it also has task measures, which I talked about in the first part of the talk, which is on social reward responsivity, but also has measures of sensory preference. So here is a short video of how the assessment goes. So this is a sensory sensitivity assessment. This is a preferential looking assessment. So this is a social reward responsivity assessment. And so you get an idea. And we also have a free play measure that we videotape. The interesting thing was the innovation that we had to do, because in the lab we were doing using eye trackers, but eye trackers are expensive and fiddly, and we cannot really take it to the field. So what we are doing in this app is to do tablet-based eye tracking. The front camera of the tablet can detect if the gaze is to the left or the right, and we get over 90% accuracy in field settings, and we can tell whether the child is looking more toward the social reward or the non-social reward. And I've already talked to you about this button task where you press a button and you see a non-social or a social stimuli, and you press another button and that you see a social stimulus. Yeah. So and this is where we see motor coordination, visual motor coordination. We're looking at how efficiently does a child trace the trajectory of this flying bee, and we map the errors, the small motor errors that the child might do. So we completed the proof of principle of this study in about 131 children in India, just in and around Delhi, autistic children with intellectual disability, and typically developing children. And most of our metrics do a very good job of discriminating the typically developing children from the autistic children. The tricky part, though, was that autistic children and the intellectual children with intellectual disability, they were not very well discriminated by any of these individual metrics. But however, if we combined all the metrics that we generated and threw them into a machine learning classifier with the usual 3-part classification, we get about 79% classification, 3-group classification using all the different metrics. So here is this, yeah. Just finishing up. Here's the summary from this second part where where I talked about the challenges of assessing autism phenotype outside the lab, and also talked about scalable neuroscience, how some of the lab-based insights are coming into the field. Our current work is taking this beyond autism and really assessing neurodevelopment in different domains in large-scale field studies. Just want to thank my team and also the funders. Thank you.
Thank you very much, Bhismadev. Really fascinating. I actually had a question that it's so burning that I'm going to use my prerogative. When during the pandemic, there was this joke in Norway that with the social distancing restrictions of 2 meters, that the Norwegians were complaining that they were being made to come closer to within 2 meters of each other, whereas they're usually so used to being so far. And then I'm not an expert in India, but I've traveled around India, and it's a very different culture. I mean, it's a much more tactile culture. People hold your hand and things. I guess my question would be whether if you ran this kind of exercise with different cultures, whether they, irrespective of whether they're on the spectrum or not, whether you get different preferences for social rewards amongst different cultures, which might have a cultural framework that is less inclined to, I don't know, send you towards social reward systems.
Absolutely. No, this is such a brilliant question, and the normative data does not exist. I mean, we would be able to address this question with the data that we are collecting, because we are collecting from different cultures. But you would think that there would be plenty of data on this, but no. I mean, especially in paradigms like these, the normative data doesn't exist. But there is also a tricky issue about that, is that the stimuli that we're using, at least the ones that I showed you in the lab, they are culturally tailored. So the stimuli we are using in India or another project in Malawi are different to the ones that we are using in UK. So in order to really do a cultural comparison of cultures in social motivation or social reward responsivity, we need to have culturally tailored stimuli and match those things. The matching aspect is very crucial.
Yeah, no, absolutely. No, thank you very much. We might find that all Norwegians are autistic to a degree by this definition. Are there any other questions before we move on?
I can ask one.
Yes, sir.
So this was fantastic, really. What you're doing is great. I mean, I feel so useless in my research that I couldn't touch all those people with my ideas, but you're doing this. This is fantastic. So while listening, I was going to ask if you're considering machine learning techniques to data mine of what you're currently collecting, and you answered that. So my question is, what the machine would look at, which parameter it will look at to learn about this autistic science?
Right.
You described it as a visual tracking, but
so I think so each of those different tasks in the app generate several metrics. So for example, with the motor task, for example, we have root mean square error, we have the force with which you're hitting the tablet, we have speed, acceleration, and the multiple differentials of those. And so we throw most of them into the bag when we try to predict. We try to be as theoretical in when we are coming to the machine learning approach, and then we would try to predict the diagnostic status, autism, intellectual disability, or typically developing in that. But there are I would say it's not completely a theoretical. So the metrics that we throw into the mix, we believe that in principle they should be they should be the ones that should come up with group differences. Yeah, so each task has separate metrics, but then we pool all of those metrics together and then see if any combination or whatsoever can predict group differences.